And we did it. This is a pretty monumental moment for me. Still some work to do, as you can see, but this is significantly better than it was. Um, Things are looking smooth. It's actually fairly comparable to the game. Let me see if I still have it open here. Kind of show it to you really quick, side by side. Um, yeah, so it's not bad, right? So this is really smooth. This is pretty smooth. So we're getting there. But yeah, this is a significant change to the very blocky effect that you'll notice from all of the previous videos. So let me kind of walk you through how I did it. Um, cool. So I came to the realization earlier today when I was just thinking this through that um, that basically I could implement this snapping effect, right? And that's exactly what I ended up doing. So you'll notice when when I let go of the key, it finishes its movement into the next block. Um, and I sort of had this thought that how I could achieve this is a combination of velocity and sort of snapping. So when I push one of the arrow keys, initiating movement, this basically starts an animation to the next frame, right? To the next sort of 16 pixel block. Um, and then basically it blocks all movement during that time. So while this animation is in progress, you can't sort of like continue to move. Um, and the effect of this is that I can have whatever velocity I want, and it'll sort of snap into the right blocks. And now my collision detection still works. So this is really a good combination, I think. I'm still looking into some possible performance issues. I'm noticing like when I go to change directions, sometimes it's a little bit laggy. Not totally sure if that's a performance issue or if that's simply, a matter of event listeners not firing as quickly as I would expect them to. Because I don't know if you hear me tapping right now, but I can change directions quite easily if I sort of tap continuously. But when I hold down the arrow keys and then switch directions, that's very slow for some reason. So I still need to look into that. But let me show you how I implemented this code. So if we pan over here to the code here, in this listen for user input, this is where I'm listening to the key down function. And previously I had this under a underscore throttle function. I've since removed that. I might bring it back, we'll see. But I didn't want to have too many variables working at once here, so I just removed it. So any key down that's coming through is coming through this function, and it's not being throttled in any way. But the thing you'll notice is right here. So first of all, this is basically not going to try to initiate a movement if a movement is currently in progress. So that's what you're seeing here. So as long as a movement isn't in progress, it asks the overworld, can I move to this next block? And then if we can, it goes forward and moves. So let's pan over into the player class now. And I've added two sort of variables to the state. One is remaining pixels for movement, and the other is movement in progress. The movement in progress is mostly a convenience state variable. It just allows for more readable syntax, in my opinion, for a lot of places. But this remaining pixels for movement, this is an important one. So if we come down here to the move function, this is actually quite simple. I'm really happy with how this came out because it actually simplified the code. So I think that's means it's a decent solution. So this function changed quite a bit. And what you're going to see here is as long as a movement is not in progress, and as long as I can move, as long as I'm not blocked by the overworld, then it sets the remaining pixels for movement to the width of the sprite character. So these are square characters, so the width and the height are the same. So it basically says, okay, you have 16 pixels left to move. And then it says there's a movement in progress. And that's all this move function does, is it sets the direction and it sets the remaining pixels for movement. And now when we go into the tick method, if there are remaining pixels for movement, then this is where the velocity comes into play. So this right here is just determining if the velocity is higher than the remaining pixels for movement, then it's going to set the amount that I need to move to the remaining pixel. Now this is just basically allowing me to have whatever velocity I want. In this case, 1.25 just was the number that felt right. It felt closest to the game. If I were to just do 1, then I would always have even numbers, and I wouldn't really have to have this. I would never have a scenario where I would be sort of, midway. But because of this, I needed to have this where I could snap into the right block. And so basically, if there is remaining pixels that need to be moved, then this is where it's happening in the tick function. So we're just basically incrementing or decrementing the x and y based on the velocity and based on the direction that we're moving. And that's pretty much it. And with this, we now have smooth movement. If you guys have a better way of doing this, or if you have any feedback, I'd love to hear it. But that's it for tonight. Thanks for watching.